So it says here, given the following sets, determine which are functions. Now, with functions, we need a one input giving us one output. Okay, so we need a one-to-one relationship of x to y. Now, it's okay for two x's, two different x's, so x1, x2, to give us the same y. What isn't allowed though is when we have an x, one x that has two possible outputs. Okay, we have y1, y2 here, and that is not allowed. Okay, this is not a function. Each input can only have one output. So any 1 to 2 or 1 to 3 relationship we have to consider not function because it will not pass the vertical line test. Okay, we'll have two y's for the same x, which means that it doesn't pass the vertical line test. So looking at A, we can see that the p value maps onto L, but it also maps onto N. Right there, it does not pass the vertical line test. Okay, so that is not a function. We have a few instances of this as well. We have this R as well that maps onto two different components, and that's not allowed. So it's a non-function. Okay, so as long we can have two different x's map onto the same y. For example, here we have 2 mapping onto 8, 4 mapping onto 8. That's okay, but b is not a function because it doesn't pass the function test when we look at 2. 2 maps onto 6, it maps onto 3, 8, and it maps onto 10. There's more than one value that maps onto, so it doesn't pass the vertical line test for that. If we take a look at the number 3, the input of 3, same thing with the input of 3, it maps onto two different outputs, not possible for functions. So we have to consider this not a function. C is a one-to-one function. This is definitely a function. Okay? It passes a vertical line test. Each input has a singular output. Now this is actually kind of special because this one here, it not only is it a function going from left to right, it is also a function going backwards. So its inverse is also a function. So this is a nice function because the inverse and itself are both functions. Okay, and not all functions follow that. And it's nice when we have those because those are easier to deal with. Looking at D again does not pass the function test because we have, if we just even look at the first input of 10, it's already mapping onto two different outputs, not a function. Okay, and we can see multiple examples of this in D because we have also 12. It maps onto 3 different things. 15 maps onto 2. Okay, the only one that actually does pass the vertical line test is the input of 25. It just maps onto 5. So which of the following relations are functions? Here we don't need to use that arrow diagram. We can use a simpler relationship, and we can just look at the vertical line test. So I can take a look at take this vertical line, and I can test that on function 1. So the vertical line, it does not pass two different places in 1, so that passes the vertical line test. If I apply that to 2, yeah, definitely we have 2 points where it crosses, so this does not pass the vertical line test. So 2 is not a function. 3 passes a function test. Every input has one output. The vertical line does not cross twice. And then for 4, it looks like it's a function, except if we take a look at that, right at those points there, because those are both closed circles, there it doesn't pass the vertical line test right at those points where it jumps. Okay, same here. We have 2 points that overlap. one input has two outputs. It doesn't pass the vertical line test there, so this is not a function. It's a function for most of it, but just at those endpoints, it's not a function. So we have function, we have a function for 1 and 3, and 2 and 4 do not pass the function test.